Welcome to Foundations in Pre-Cal 10. This is outcome 10.06, lesson 1 on representing relations. So in this lesson, basically, we are going to look at mathematical relations, which is just two sets of numbers that have some kind of a pattern representing between them. And we will look at different ways of representing those relations, all just a bunch of different ways of saying the same things. We're just going to get our head wrapped around a little bit of the vocabulary that is involved, okay? So if there is a relationship or some kind of a rule or some similarity where you can see how you get one number from another number in a set, then there is a mathematical relation that exists, okay? And relations can be represented with a table of values. You may have seen these in science classes before when you do a science lab, like you might have distance and time and you record pairs of information, right? Like you maybe you are walking 5 meters and every 5 meters you record the time from the beginning and you can put it in a set of tables or a table of values. Okay, so that's one way. We could also take the graph because remember that this table of values, these points, so for example, the point -1, -5. So if I go to my graph and on the x-axis I go to -1 and on the y-axis I go to -5, there would be a point there at -1, -5. And if I had a point at 0 and -3, so that's that point there. So if I plot all of these points, then you can draw a line through those points and you can get a graph. And we'll talk about when it's appropriate to connect the dots and when we don't in a little bit. So we can do a table of values, a graph. We could also talk about words. So if we look at this set of values, we could say that one number is 3 less than twice the other number. So basically what that means is if I double my x value, we'll look at the words and the equation here at the same time because those two are closely related to one another. If I double the value of my x and subtract 3, I'll get the y value. So for example, if I double 2, that gives me 4. Take away 3 gives me 1. If I double 3, that gives me 6. Take away 3, that gives me 3. You'll see that that rule works for every pair in our table of values. So you can use a word, you can use an equation. You can also write them as a set of ordered pairs. So basically all that is taking the numbers from the table. So if I had these are my x values and these are my y values. So keeping in mind that an ordered pair is an x and then a y. So we have each pair of numbers. So you can see that is my first ordered pair there and so on. It's just another way of representing them. Those correspond to the points that we graph when we graph them. Another way, this would be a new one, is called an arrow diagram. So all that an arrow diagram is if you take a peek, it basically looks exactly the same as the table of values. We have one set of numbers in one circle, another set of numbers in another circle, and then we draw these arrows basically saying that these two are linked together. These two are linked, these two are linked, these two are linked, and those two are linked. Okay, so those are just different ways, and we'll do an example in just a minute. One other very important set of words that we're going to look at are the words domain and range. Okay, so domain is all of the x values. Okay, the x values are my domain. And my range are all of the y values, okay? So in my set of ordered pairs, all of my x's are in my domain, and all of my y's are in my range. All right? Let's go ahead and do an example and just talk about how we go in the sets. So here we have, if students want to see a complete reflection of themselves in a mirror that was fixed to a flat wall, they have to use a mirror that's long enough, and the information displayed in the table is the data that we collected. So we can see that if a student's 120 centimeters tall, they need a mirror that's 60 centimeters long. 110 centimeters, you need a 55 centimeter. Okay, so here is a table of values. I want you to write the same relation using ordered pairs, okay? And I don't have x and y here, I have h and l. So the h is going to come first, and the L is going to come second in my ordered pair. So I'm just basically taking each pair of numbers and writing them as a set of ordered pairs. So I would have 120 is paired with 60, 110 is paired with 55. 100 is paired with 50. 90 is paired with 45. And 80 is paired with 40. Okay, so that's just a set of ordered pairs. The domain and range, so this will be something new, and we're going to have a whole lesson on this in a little bit. But the domain, so this is, we have to use what's called set notation, okay? So we use a capital letter to represent what it is we're finding. So we're finding the domain equals, we use curly brackets to represent a set. And then what we do is we give all of those values that are the X values in the ordered pair, or in this case, the H values, okay? So we list them all out, and generally speaking, we always go from lowest to highest. So it'll be 80, 90, 100, 110, and 120, okay? And then for the range, capital letter R tells me I'm in the range. And we are going to, again, list each of the Y values, or in this case, the L values, from my table of values from lowest to highest: 40, 45, 50, 55, and 60. And set with a curly bracket. C says to show an arrow diagram. So remember, I need a little bit of more space, so I'm just going to move over here for this. The arrow diagram, we take basically a little oval for each of them. In the first oval, we put our X values, or our domain, which is 120, 110, 100, 90, 80. And in the second one, we put our Y values, or our range: 66, 55, 50, 45, 40. And then we just draw an arrow showing that 120 is paired with 60. This one's fairly self-explanatory because each number goes to the one that's directly across from it. We'll see some in a little bit that are not quite so simple. Describing the relation in words. So if we look at the numbers, we're trying to figure out how can I get from my height to my mirror length, or vice versa. So if you notice, height of 120 needs a mirror of 60. We could say that the mirror must be half as tall as the student, or you could say that the student is twice as tall as the mirror. They mean the same thing, right? So let's just write the mirror is half as tall as the student. Okay, so that's describing the relationship in words. And then we can draw a graph. Okay, so remember that your domain is your X values, or in this case it's H, and your range is your Y. So what I know is that at 120, I am at 60. This is a little tough to graph here. 110, I'm at 55, so that is partway through, which is not ideal, but it's there. 100 is 50, 90 is 45, and 80 is 40. So we get that set of points. Okay, now we have to think about, I'm just going to jump down to the after F. It says, would it make sense to join the points in this graph? So we have two kind of sets of information. We have what's called continuous and discrete data. Okay, so down here we talk about, we'll come back to the equation in just a second, but we have continuous and discrete. Continuous is when I would draw a line between, and discrete means I leave it as points. So in order to figure out if it's continuous or discrete, you have to ask yourself, because right now we have plotted very specific points at, let's say, the height of the student, say, of 120, 110, 190, and 80. We have to ask ourselves, is it reasonable that I could have a student with a height between 110 and 120 centimeters? Okay. And obviously the answer is yes. You don't go from 110 and then immediately you're 120. You are in between for that entire length of time. So this would be a set of data that it would make sense that would be continuous. So you should take a ruler and you want to connect the dots. I don't have a ruler here, so I'm going to try my best. Oops. And that's a thick line too, but you'll have a line through your data. That is continuous. An example of discrete data might be something like if you were making a graph of, like, if I buy one concert ticket, it costs $50. If I buy two concert tickets, it costs me $100. If I buy three, it costs me $150. And in that case, it wouldn't make sense to connect the dots because you can't buy 1.5 concert tickets. You can only buy a whole number of tickets. So 1, 2, 3, 4, 5. So that would make sense that you would just have the points on the graph. And that would be an example of discrete data. Okay. Lastly, to write an equation for the relation, so we want to use the variables that were given, H and L, And I always find it's easiest to refer to the words. So it says the mirror is half as tall as the student, right? So the mirror height is represented with length. So length is half of the height of the student. Okay. You could also, if you used words the opposite way, you could say that the height of the student is twice the length of the mirror. So you could also have it like that. Okay. So what I want you to do is go ahead and practice the practice questions, which is just going back and forth between the types of information.